Hi everyone, today I will introduce VGGNet. It is proposed by VGG Vision Lab and it is a very famous network. It has several features. Firstly, it is deeper. AlexNet only has 8 layers, whereas VGG has 16 layers or even 19 layers. The depth doubles within 2 years. This is one of the reasons why it's famous. Another reason is that it proposes the small kernel stacks. Let's take a look at AlexNet. It has 5 conv layers and 3 full Ethernet layers, and we need to write the same number of lines of code as the number of layers. But VGGNet has 16 layers or even 19 layers. Does it mean that each layer we need to write one corresponding line of code? No, it doesn't go like that. It uses blocks to represent the network. For example, we define a block of 2 conv layers and another block of 3 conv layers. This block is repeated for 3 times, and this block is repeated for 2 times. Similarly, for VGG19, this block is repeated for 3 times, and this block is repeated for 2 times. It is more like that they define a class where we only need to give the number of input channel and output channel, and also the number of layers. The yellow area is a block, and we can also add max pooling into the block. And implementing a network is more like a procedure of building blocks. The block consists of conv layers, and the network consists of several blocks, so that the code will be much more efficient. Imagine without it, we need to write 100 lines of code for a 100-layer network. That would be a disaster, and there will be a lot of Ctrl-C, Ctrl-V. Let's take a look at the code. I copied this part from PyTorch GitHub. It's not exactly the same as defining block as a class. Instead, it used this to represent VGG11, VGG13, VGG16, and VGG19. And this is a block. 128 and M, this is another block, and so on and so forth. And this make layers is to build one network. Let's take a look at VGG11 as an example. So the output will be the layers, and the input channel, it is firstly 3, and it reads all the elements in this list. If V equals to M, then it means that it's a max pooling layer. It will add one max pooling layer to the layers. Otherwise, it will be a number. It will be the output channel number. So it will first cast it to int and then build a conv to the layer. The input channel is 3 at first, and then output channel is 64, and kernel size equal to 3, padding equals to 1. If batch norm equals to true, then after conv there will be a batch norm and a ReLU. Otherwise, there will be only a ReLU after conv to V. And then the input channel number will be replaced by this V, and then goes to the next round. And finally, it returns the whole network. The other feature of VGGNet is that the number of channels increases in the power of 2. Let's take a look at AlexNet. The number of channels isn't the power of 2, such as 96, 384. But for VGG16 and VGG19, the channels number is always the power of 2, like 64, 128, 256, 5, and 12. Why? Because it will make full use of the computation resources, and it is proved by the power of 2 gets the fastest computation speed. And later on, when people define networks, they also use the power of 2. VGGNet has 2 major drawbacks. It is painfully slow to train, and secondly, the network architecture weights themselves are quite large. So sometimes people prefer to use lightweight network such as SqueezeNet, ShuffleNet, but sometimes VGGNet is preferred because when we deploy models onto some mobile AI chips, some operations may not be recognized by the board, but VGGNet has the most commonly used operations, such as conv, max pooling, full Ethernet layer, so it is preferred when deploying to small chips.